ZK proofs are a powerful technology that can solve some of the problems that Bitcoin faces due to the increased use of ordinals and BRC-20 tokens. These tokens are inscribed onto the Bitcoin blockchain and consume a lot of space and fees, leading to network congestion and frustration for users. ZK proofs can help by reducing the amount of data that needs to be verified on the blockchain, while preserving privacy and security. To understand how ZK proofs work, let's use a restaurant analogy. Imagine that you want to order a pizza from a restaurant that accepts Bitcoin as payment. You have two options: you can either pay directly with Bitcoin, or you can use a BRC-20 token that represents a pizza voucher. If you pay with Bitcoin, you need to broadcast your transaction to the whole network, which means that everyone can see how much you paid, when you paid, and where you paid. This also means that your transaction has to compete with other transactions for space in the next block, which may take a long time and cost a lot of fees. If you pay with a BRC-20 token, you need to use a smart contract that inscribes your token transfer onto the Bitcoin blockchain. This way, you can use your pizza voucher to pay for your pizza without revealing your identity or spending habits. However, this also means that your transaction takes up even more space and fees than a regular Bitcoin transaction, because it involves extra data and computation. This is where ZK proofs come in. ZK proofs are a way of proving that something is true without revealing any information about it. For example, you can prove that you have a valid pizza voucher without showing the voucher itself. You can also prove that you transferred the voucher to the restaurant without showing the details of the transfer. ZK proofs can be used to create a layer on top of the Bitcoin blockchain that allows users to transact with BRC-20 tokens without congesting the network or compromising their privacy. Instead of inscribing every token transfer onto the blockchain, users can batch their transfers into a single proof that verifies their validity and correctness. This proof can then be inscribed onto the blockchain with much less data and fees than individual transactions. This way, ZK proofs can solve both the Ordinal and BRC-20 issues that Bitcoin faces. They can enable users to access more functionality and value on top of Bitcoin without sacrificing its integrity and efficiency. They can also enhance the privacy and security of users by hiding their identities and activities from prying eyes.